Okay, great. Good afternoon, everybody. We're going to go ahead and get started. Okay. Quick announcement. Somebody lost a small ring here. So if you're missing a ring, anybody here? No? Should I make it else?
We will be putting at the team desk.
Clicker holding. All right, good morning, everybody. We're gonna go ahead and get started. Technical session 3B. First, we're gonna introduce Andrew Pearson. Andrew is a native of Decatur, Georgia. He graduated from Southern Polytechnic State University in 2012 with a bachelor's degree in civil engineering technology. He began his career with GDOT in 2014 with District 2 Traffic Operations Office. In 2017, he accepted a position with the State Traffic Operations Office, TMC, shortly thereafter, becoming the Plan Review Concept Design Supervisor. And most recently, since July 22, Andrew has been serving as the State Traffic Operations Manager over signal permits, access management, and the Operational Improvement Program. In his free time, Andrew enjoys trying new restaurants with his wife, Amanda, collecting comic books, and this is something I relate with very well as a fellow season ticket holder, watching the Falcons seemingly find new ways to disappoint him on Sundays. So everybody, please welcome Andrew Pearson.
Good morning. So I'm going to talk to you guys about the Operational Improvement Program this morning. So the program, what is it? Historically, small improvements have been necessary along our roadways, even after large-scale projects come through. So in 2010, GDOT senior management realized there was a need for a change. And so we came up with a program that was designed to deliver low cost and high benefit projects. And with the program goals being to reduce delay, increase throughput, and then we have a targeted delivery time of between 12 and 18 months. So we're going to go through kind of from solicitation to development to approval to delivery. So the program, we split the program down the middle of the state. The eastern side of the state is handled by Kimberly Horn, and then that's districts 1, 2, 5, and then the eastern side of Clayton, or eastern side of District 7, and then the western side is Region 2, which is is managed by Arcadis, and they have the western side of District 7. So solicitation, we get our ideas from just about anywhere, honestly. Starts within our office of traffic operations. We all live in various different places throughout the metro area. So for me, I live in South DeKalb, so I'm like, I can tell you what's wrong in South DeKalb. We got my PMs, some of them live in Alpharetta, some of them live up in Cherokee County. So we try to bring our own individual knowledge base for what we're seeing out on the roads and kind of seeing what we can do from that standpoint. Then we also meet with the districts weekly. So we're getting the know-how, we're getting essentially the information from the districts, them letting us know what they're seeing, what they're hearing from the local municipalities within their district. Local governments themselves, sometimes we'll reach out to local governments individually and just kind of hear what they have to say. Especially, this is more important for like your bigger municipalities, like your city of Atlanta, your Gwinnett counties, your Chatham counties, your Cobb counties, things of that nature. Upper management is off. They are not shy about letting us know, like, hey, you guys need to go fix something here, and like we don't know we don't know how you're going to fix it, but you need to go fix it. And then we also utilize the RIDIS tool. How many of you guys are familiar with RIDIS? Okay, so we utilize the RIDIS tool, and we'll kind of get that to the next slide. And then we have other. So other is pretty broad, but like I know my parents would be like, hey, what's going on here? Like, can you fix that? I'm like, no, that's off system. Like, that's not something we deal with. But I mean, oftentimes you just talk to anybody, people will let you know, like, there's something wrong with this signal or there's something wrong with that. So we get information just from just pretty much anywhere. So I mentioned RIDIS. So what we do, I would say quarterly, we come up with our RIDIS 300 list, which is just the top 300 list of intersections that experience congestion throughout the state. You can't read this information. This is probably from like the top 50 to 75 or 80. But like the top one there is like US 19 at Terra Road. Next one is Georgia 21 at Georgia 204 down in Chatham County. And so we kind of go through this list of locations, and we'll kind of screen them out. So sometimes we may be able to do something. So I know we have a project at 19 at Terra. And we also have one at 19 or Georgia 21 at Georgia 204. But some of these locations aren't always viable for our program. So I just showed you the idea database essentially. So when we're looking at whether or not a location is viable for our program, we're looking at if it's going to cost a lot of money essentially to construct. We're looking at right-of-way impacts, environmental impacts. Something I didn't mention on the screen, we're looking at utility impacts as well, and then there's benefit or need for the project. So what our program operates on is the BC ratio. So we're looking at the benefit cost ratio and kind of trying to see, but obviously the higher the BC ratio, the more viable the project is typically. So we're generally trying to avoid anything with high right-of-way impacts, or we're going to end up affecting large amounts of utilities. We're trying to generally avoid those kind of things. So that's going to, one, delay the project, and two, is going to end up driving up the cost of the project. And then, so after that, after we determine that the location is viable, we'll come up with our synopsis packages. So this is a cover sheet. So this particular location is State Route 236, Hugh Hollow Road and Mount Industrial Boulevard. And I know you can't read a lot of this information, but what we generally provide is an aerial shot of the existing location, the delay it's currently experiencing, what the expected delay will be if we don't build anything there, and then we're looking 20 years out as well to see what the delay is going to be at that point as well. And so we have a summary of just what our expected improvements are. Then down the lower section, the lower right, we have the breakout of what P is going to cost, what utility costs would be, what right-of-way costs would be, and the construction cost. Okay, so after we come up with a synopsis package, what we have to do then is present it to what we call the Operational Improvement Committee. And that consists of our chief engineer, then the division directors over engineering, operations, the state traffic engineer, then the state transportation planning administrator, and then other offices may be called in to sit in those meetings just to make sure we're not overlooking something and getting those projects approved. So after those projects are approved by the committee, they'll be programmed, and we have multiple options for how we program. Sometimes we have quick response projects, which won't necessarily have to go through the committee. But usually our quick response projects are significantly cheaper with a cap of about $200,000. And usually the districts handle those themselves. We give them the idea, we tell them, okay, here's what needs to be done, and we'll send it to them, and they'll, usually through their state aid office, they'll get those projects completed. So what has the program accomplished? We've looked at over a total of over 1,100 locations throughout the state, and we've programmed 77 quick response projects. Currently, we have around 415 projects that are currently active. And when I say active, that's projects in various stages. So we were currently screening them. They're currently under construction, synopsis package, quick responses. So we got about 415 active projects currently. You can see the breakdown. So obviously District 7 is going to have a good bit of projects there. Then you look down District 4, where you only have like a total of 15. So it makes sense when you look at just the demographics and how like the population spread out throughout the state. So what I'm going to do now is kind of go over three locations that we've three projects that have gone through the entire process and currently or two of them are currently completed. One is about to begin. So this one's State Route 85, 279. This is in Fayette County. This is essentially what I like to call like our bread and butter as far as the operational improvement program is considered. Really what we like to do is extend turn lanes, add turn lanes wherever we can. So if we're looking at, so we'll go to this next screen. So what we essentially did here is utilize the type A median, and then we just widen into the median and then offset the left turn lane. So now we're going to make that protected permissive, which give them a little more time to make that left turn movement, which is going to help traffic along the corridor. And then the same thing in the northbound direction. Sheet. So this is just what it looked like originally under construction, and this is what it currently looks like. The next location is State Route 236 at US 78 at the ramps. So what we did here, so this location is a good example just because this is we're looking at someplace where we're not going to have any kind of right-of-way issues because it's all state right-of-way. The utilities are going to be pretty minimal here because there shouldn't be any kind of utility poles in the general vicinity of what we were planning on doing. So what we looked at doing was there's a problem with weaving along the ramp to the top of the screen. So what we did was we just made it yield controlled, and then we extended the right turn lane. So essentially you would, instead of making them kind of weave, because previously it was free flow. So instead of it being free flow, it's made it yield controlled. And then after they get it on to 236, they'd have the option to either stay in the through lane along 236, or they can get over to the right turn lane, which will take them to Stone Mountain Road. And then on the southern ramp, what we did there also is that we just better aligned the ramp. So before it was kind of making it a merge movement for traffic. And I know a lot of people just don't really like those moves when you're merging in from the left, and it just makes people uncomfortable. So what we did there is kind of make the angle a little more favorable. And then so people operate a little more efficiently and be a little bit safer for drivers as well. So this is what it initially looked like under construction, and this is what it looks like now. Something also worth mentioning for this location was that at the top of the intersection, there's Old Stone Mountain Road and there's Stone Mountain Road. That's off system, but we did notice when we were going through the analysis of this location that any kind of improvement we could have done at that location would have an impact down the ramps. So we ended up coordinating with, I believe that's still DeKalb County at that location. We ended up coordinating with them, and they were able to do that separate from our project, but it ended up having additional benefits as a whole for the entire location. The last location we're going to look at is State Route 121 Peach Orchard Road at I-520, so just not too far from where we are currently. So this is another interchange. We're doing a lot of work here. Like I said, this project is we're about to begin design for this, but what we're proposing is just adding some additional left turn lanes along the eastbound approach for 520, and the same thing going westbound. We're adding a additional left turn lane because if you you'll see here along Peach Orchard where we're essentially utilizing the existing lane widths. So currently there's three through lanes and one left turn lane. What we're going to do is essentially have one of the inside most through lane. We're going to have that drop into what's going to now be dual left turn lanes. And then we're going to continue the 2 through lanes through the interchange. And then we'll pick back up on the third lane after you exit the interchange. And the same thing here, we're just going to add a left turn lane. So you're going to have the dual left movement along with the 2 through movement. So you have a shared through left, and you have a dedicated through movement as well. This location, so if you go back, see, I know you can't see that down there, but the construction cost for this one's about 1.1 million, which is kind of high for our program. We generally try to keep those construction costs a little bit lower than that. But the reason why this project is a bit more expensive is because you'll see this, we're proposing the gravity wall. You'll see here with the grade just right there adjacent the ramp that we're going to have to build a gravity wall. So that's kind of going to drive up the cost of the project. But we did find this project just to be, with the amount of traffic that comes to this interchange, the benefit's going to be there that offset the cost, and it still made it a pretty viable project. So we go over here. So we're adding a right turn lane from Windsor Spring, and then we're adding the left turn lane, which essentially it's not really a CD, but it's essentially feeding from Peach Orchard, and then head for traffic headed towards 520 in the westbound direction. And so since we're adding the dual left turn lanes on Peach Orchard, we want to separate the left turn movement. So now the dual lefts come, they'll have the 2 through lanes to go through and get onto the ramps. And then if anyone wants to go head back to the left on Windsor Spring, they have that dedicated left turn lane. So that is my presentation. You want to take questions now, or any questions? Cool.
Do you most of the design in-house, or through your team partner?
It's a little bit of both. So depending on the project, one of my consultant teams will handle it. So Chuck, where's Chuck? There's Chuck. Chuck's with Arcadis. Sometimes our Arcadis will do some of the design. So we have like part of our contract allows for them to do some of the design work there. And then if it's say a little more complicated, we may just contract that out, put that to the put out for bid for somebody else to do the design work. Yes.
Are these projects that GDOT typically initiates, or is it something that local governments come to you guys and those projects?
It's a little bit of both, honestly. I find that sometimes local governments reach out to us, and I think those tend to be the more fruitful projects, because if they're reaching out to us, then that means they have some stake in it, and hopefully they may be willing to contribute some funds. I mean, sometimes that's not always the case, but it'd be great because that helps with our BC ratio, and they're getting something out of it as well. So it's a little bit of give and take. Yeah.
Feeding projects from the FinOps program.
We do, sometimes like, so glad you mentioned that. So our SIGOPS program, we try to discuss it with all of our offices. So whether it's SIGOPS, whether it's safety, sometimes our safety office will look at a location and determine it's not viable for a safety program. Say, hey, this might work for you guys. So we'll take a look at it. And same thing for SIGOPS. SIGOPS might look at it like, yeah, we've tried retiming this signal 5 times. It's just not working. Like, see what you guys can do with it. So yeah, we try to communicate within the office, trying to bounce ideas off each other and see if we can do something that they weren't able to have. Yes.
Talk a little bit about the costs that are see what about the benefits? Right categories of benefits.
Well, the last part, sorry.
For the benefits and the BC ratio. Maybe that's
It's typically a good BC ratio.
Yeah.
Okay. Okay. So sorry. So a good one, we try to shoot for 10 as the baseline. That's not always feasible. So we've had a couple of roundabouts, and roundabouts tend to get a bit more complicated, involve a lot more design and just construction. So sometimes those drive that benefit cost down a little bit lower. If it's in the metro area, then there might be enough usage of that roadway or that intersection that helps the benefit cost. It makes it more of a vital program. But we've got one that we just presented to the committee back in the middle of February that was, we had a BC around 7, I believe. And it's just because of the location, it was down in District 4, I believe. So the traffic wasn't super heavy, but we did see some benefits. So that's kind of why the benefit wasn't there. But we're looking at just how much the roadway or the users. So like you're getting 2 million people going through an intersection, then like compared to somewhere in South Georgia where you're getting 50,000, like the benefit's not always going to be there. Any other questions? Yeah. So that's the answer to the question is yes. We can't do it. It's legislature. So it's a law that like we can't spend more than $200,000, or the districts can't spend more than $200,000 on a project. So that's really kind of been hindering us, because what we used to be able to do for 200,000, we used to be able to get like a 400-foot right turn lane in for 200,000, we'll just say. And now it's like, okay, we can get 150-foot left turn lane in for under 200,000. And so there are currently discussions with raising that cap. So hopefully that gets approved, and then we can do a little bit more work out there, because a lot of times I forgot who mentioned it yesterday, but might have been Andrew, our construction bids coming in 40% higher than what we were initially projecting. So those are some of the challenges that we're dealing with right now. Yes.
Piggyback on the BC question, so do you have a cost like associated with like additional use to serve, or like a cost associated with like the much smaller delay that you're seeing? And how do you get that top?
Yes, there is we have a spreadsheet that we kind of utilize, and so that's kind of what helps us get that information. Yeah. Thank you.
All right, thank you, Andrew, for that wonderful presentation. All right, next we're going to move on to Greg Ramsey. Greg Ramsey is the Director of Public Works and Engineering for the City of Peachtree Corners, Georgia, and the Chief Engineering Officer for the Curiosity Lab. He is responsible for managing municipal operations and maintenance of all the city's infrastructure. He oversees engineering, land development, stormwater, regulatory compliance, municipal solid waste, right-of-way maintenance, traffic, and transportation. He is a Georgia Tech graduate, licensed professional engineer, and has over 26 years of experience in municipal engineering and public works. Please welcome Greg Ramsey.
Thank you very much. I don't know if you were noting that, but he said Chief Engineering Officer, which is CEO, which is an added title, but they didn't give me any more pay. Yeah. We should have intermission music for the transition. All right, there we go. So I am from Peachtree Corners. Even as late as last night during dinner, I had to tell somebody where Peachtree Corners was. So we have a little bit of an identity crisis, which is a lot about why we did this project in the first place. This is our Golden Bridge over 141, Southwest Gwinnett County. Gets a lot of attention. I always say that's the place where the bridge crosses Peachtree Parkway, and everybody knows. A little bit about Peachtree Corners, just for those of you who don't know where we are. We are not Peachtree City. First driving down our roads. We are in Southwest Gwinnett. We're the biggest city in Gwinnett County, which is something also is a surprise to a lot of people. We have a perfect balance of residential community and jobs. We have 45,000 of each, which is a perfect blend for a government to operate. We actually have zero property tax, so nobody pays any property tax. They get us for free, which helps when they call to complain about roads or garbage, stormwater, or just in general being a curmudgeon. They call and say, what are you going to do about it? And we're paying your salary to fix our problems. When you're going to start? Like, actually, you get me for free. So good luck. All kidding aside, city's 10 years old last summer, celebrated our 10-year anniversary. And so we're now in our 10th and a half year. We're excited to celebrate a project like this. City started, the area was developed in the 70s. Georgia Tech graduate named Paul Duke built one of the first live, work, and play communities, and he called it Peachtree Corners. Wanted to save some of the area's technology students, particularly Georgia Tech students, from moving to places like New York or Silicon Valley. Wanted to build an economic development base where the Georgia economy can be boosted by smart technology people. And those graduated from Georgia Tech could come live there, work there, build the economy, build the community. And that's where Peachtree Corners bases began. Now we're home to these companies like this. Some Fortune 500 companies are based there. We have numerous engineering companies, probably some of you all that have regional headquarters in Peachtree Corners, happy about that. Confluence of some major roads, 141, 13, 140, which is north of 285. So a big convergence of traffic, big convergence of major arterials and corridors in the area, in the metro area. If you look in the very background of this picture, Mr. Duke is standing next to the sign that he built. Peachtree Corners is home to a lot of innovation. In the 70s, as evidenced by those pictures, that's Mr. Hayes on the right. It's an actual picture, allegedly. The Hayes modem was invented and developed at Peachtree Corners, as well as some Scientific Atlanta, General Electric. And it started in the 70s. So much like me, born in the 70s, we're starting to show a little bit of age. Trying to recover some of that innovation that we had. The 70s technology is obviously gone and past. And we were a city that had a little bit of an identity crisis. And so a few years ago in 2018, one of our councilmen, also a Georgia Tech graduate, you sense a theme here, it's on purpose, said, what can we do to stand out? What can we do to keep from becoming a blighted city? We're brand new. How are we going to maintain that positive movement forward? How are we going to reinvent ourselves? What can we do? We have this cool basis of technology. We need to give it a rebirth. And that's where this project came into play. We had, just like the technology was becoming dated, the infrastructure was dated. We had many 70s residential. Through the 80s, the residential blew up. All of the streets were built in the early 80s, and obviously getting into 2012, that infrastructure was beginning to age and crumble, and in many cases fall apart. And we needed to make sure that we were going to not only stabilize that, but reinvent it so it can continue to move upward. Always felt like if the cities and municipalities are moving, you're either moving up or you're moving down. Very rarely are you staying stagnant. And so we developed this project beginning in 2018. And today it's got a lot of factors. We built this, what we call the city street of the future. A lot of this is going to sound like marketing, which is weird coming from an engineer, but this was an economic development project, so it is marketing in a lot of respects. We built a 3-mile public autonomous test track. Got a cool 2020 Ford vehicle that was built in Michigan, but since has been transformed, just like our infrastructure, into a very cool, smart vehicle. And then our former City Hall building has now become an innovation center. A very cool vibe place that has a continuous flux of technology, innovation, a lot of testing. We have built a laboratory, and it's called Curiosity Lab at Peachtree Corners on purpose. Much like a chemistry lab, you don't always get it right the first time. There's always change. You evolve things. Even if you're a chef and you're into the culinary arts, you rarely get the recipe right the first time. And so there's always changes. You tweak things, you tweak the ingredients, you tweak the balance. And this project has continued to evolve. We began in 2018 with a clean slate of an old 70s era commercial suburban street. It was 38 feet wide, had the chicken lane in the middle, suicide lane, and the vehicles on the outside. And so we took that and transformed it into something we believe is more useful today, and certainly more useful for the projects than then. We started with this conceptual drawing. This is the intersection along Technology Parkway at Technology Parkway South. We do not have very creative street names at Peachtree Corners, but we have a signalized intersection here now that used to just be a 3-way stop. We imagined reinventing the two vehicle lanes on the outside and developed a concept where the vehicles are in the middle and autonomous testing lab lanes are on the outside. Created a typical section just because we're transportation engineers. And that's what it looked like at the time. And right before construction started, and then after we had reconfigured the road. Like I said, the recipe changes, the lab approach changes. This was our first iteration. You see some curbs there, some flexible bollards that are separating the lanes. First few months of this project, lots of conflicts. School buses hated us. School buses eventually decided not to come down Technology Parkway. They went another way. They actually today turn around in my front City Hall parking lot because they refuse to go down the road. They say it's too narrow. Gwinnett Transit, not big fans of us either. They like to go well over the speed limit. This was the first iteration again. So we developed some off-the-cuff chevrons to sort of mark our space out there on the outside. You'll see some signage on the far right there that was also creative. And then the bollards themselves have changed over time. This is what we have flexed to today. In addition to the transit and the school bus drivers, the autonomous shuttles themselves were having trouble with those vertical bollards. They read them as a hazard, and they couldn't ever, despite what is now our 4th year of development, they couldn't overcome that vertical impediment as reading as a hazard. So they said, we've got to get rid of the vertical bollards. We said, no, we can't. NHTSA says we can't. So we worked with some folks at NHTSA and were allowed to use what I was researching eventually became this. I found a product called Zikla, developed and used out of Spain. At the time, my boss and city manager was at the Smart City World Congress in Barcelona. I said, hey, can you go out and find some of these things? They're called zebras, and take some pictures. Barcelona has thousands of these, thousands of zebras across the city. And so we purchased those, showed up, installed them. And so now instead of a vertical bollard, we have these zebras every 20 or so feet. And that's what we're using. So even our infrastructure, as dumb as a vertical separator is, there's no technology involved, but we're having to evolve what we do for the infrastructure so that the smart stuff can still operate. And so this is the 4th iteration. We started out with white bollards. They claimed they couldn't see them. We went to blue. That was a special order, of course. Got stuck on the boat. Took forever. Fortunately, these Ziklas showed up in 11 days. They showed up in 11 days. We had it installed a few weeks later. This has so far been pretty well received. The transit guys like it better. The autonomous vehicles themselves like it better. And believe it or not, the regular vehicular drivers have complained a lot less. This will not flatten the tire, which we've tested that. It will not flatten the tire of a bus for sure, and they test that every day. And so what we've developed outside of the dumb stuff like bollards is what we're calling the street of the future. We've got this intersection that we added. This was not a warranted traffic signal. We added it just because we wanted to test it up. We've got 5G connectivity throughout the corridor, thanks to our partners at T-Mobile. We've got the shuttles there operating. Cyclists there in the green block you see are regularly using this corridor. We're about half a mile from Norcross High School, 4,000 students plus. Many of those students walk down this road to the racetrack in the morning to get coffee and various other things. And then we have standard vehicles, pedestrians. So we have an interaction here of every mode of traffic that's standard in Metro Atlanta, including the transit. I don't have a picture of the transit. They did not slow down enough for me to take a picture. And even on the top of the bottom, the right side of this, you see the transit stop. So this has everything that we need to test, to make sure everything's talking to each other, make sure all the complete data is being captured. In addition to just testing stuff, we have what you can't create in a laboratory, but you can't create in a kitchen. We have a real world road. We have a mature tree canopy. Like I said, 40 plus years of development. We have some very old trees. That car just went up a 13% grade. Believe it or not, the autonomous shuttles struggled mightily with that, especially in the rain. They still struggle in the rain, which is disconcerting, but they overcame the grade change. They overcame the sweeping curves. Sweeping curves is an economic development term for a sharp curve. And then multi-store commercial and residential areas. And then the coolest Ford in the fleet. You can see we bought that in 2020. It's got direct mode. It's got OBUs. It's talking to pedestrians if you're so inclined with your smartphone and our app. It's talking to the transportation network, the infrastructure, and all the technology that we put on the corridor. This is our former city hall, which looks much cooler than it did when I worked there. We've got innovations happening there. T-Mobile has their innovation center. You see UPS there. They have their research and development team based in Atlanta out of this center as well. UPS is developing last mile technology. They've, for about 18 months, tested with a team out of Korea, some robotic and AI equipment to deliver that last mile, such that a UPS truck could drop it off at a central location. And then we have a 3-mile loop here, thousands of offices, many of which are getting Amazon on a daily basis. And so that robotic car, was a box that looked like a zebra, was delivering packages up and down every one of those driveways. That kind of innovation is happening out of UPS in that center. We have the North American headquarters of La French Tech, which is the technology arm of the International Chamber of Commerce for the country of France. That's been fantastic. You'll see some of the data in my presentations in metric, because I've given this to them several times and they talk metric. Remember in the old days in the 90s when we did metric for a minute? Yeah. That is fast. And then a number of other things, not just traffic related, but we have had remote driving testing. Imagine a big FedEx distribution center, lots of guys driving, lots of women involved, hundreds of employees working. What if you could remotely drive those trailers around with one person? So you have one FTE instead of 100, moving things around safely, just on the yard, not driving down the road yet, but just moving them about. Logistics of backing them up, emptying, taking them to wait, and then having them into another bay to load. They did a testing for 2 years, remotely driving those trailers. And on the right, you saw teller-operated scooters. So it's like an Uber scooter. That was my term, not theirs. You could call that on your app, and that scooter would be driven to you remotely from a guy in Mexico City, believe it or not. The trailer driver was in San Jose, California. But you could have that scooter delivered to you, ride it as you see fit, inside of our boundary, of course, because we're testing. And then when you're done, tell them you're done. And it was remotely driven back to the docking station to be charged. It wasn't like downtown, Midtown, where they're just laid over in the curb, dumped on the corner, blocking the stop sign. That was in the news for a bit a couple of years ago. This was a much cleaner and more efficient way, and they're still tabulating a lot of that data to see if they can expand that system. We've had hundreds of actual people ride our shuttles. You see it's going over a solar panel in the roadway, partnership with the Ray based out of down near Columbus. We've had people ride it just for fun. They come and take pictures with their kids and ride it, but it's a level 5 autonomous shuttle right there. Does still have a steward on board. The little guy has a little Xbox controller. Stop it just in case the transit guy's coming. The level 5 guy, the steward, is still in there because NHTSA requires it. I've had numerous other technologies that we've tested. These are not renderings, these are actual videos. We've had drone delivery. Imagine if you want some Chick-fil-A for lunch, instead of having to get in your very hot car and go wait in a very long line. No matter their efficiency, it's arduous task. What if you could order Chick-fil-A instead of having it Ubered to you, it's delivered via drone? And that's the kind of the testing that they were doing. They're dropping a package of food there in that predetermined box there. It's from City Hall. On the right side, they're testing changing batteries. A huge problem with drone delivery is battery. The battery weighs a lot. Heavier the battery, the bigger the drone. And those batteries die quickly. While they wait on technology for the battery to improve, they're figuring out a way to autonomously replace the battery without having to have it done by a human. It's fantastic stuff. And then even outside of what we do, Secret Service has been here off and on over the last few years testing cybersecurity. Obviously, if somebody hacks into our system, they hack into the DOT. You've seen numerous movies where that goes awry, where they allow the bank robbers to get away because they change all the lights to green. Well, it's usually much more nefarious in nature when somebody hacks into the system. So the Secret Service has been involved in partners with us for a couple of years. This was last summer. If you look really closely, that's the former mayor of South Bend, Indiana, Mayor Pete Buttigieg, now the Secretary of Transportation. Buttigieg and his team were here last summer. He actually stuck around for a couple hours. I was expecting one of those things where the Secret Service comes in. They actually did park beside my office, which was really cool. He came in, he was here for 2 hours in our city hall. He actually called our mayor 2 weeks ago. It's one of those things, hey, can you take a mayor, can you take a call from Secretary of Transportation? Yeah, sure. It really was him calling. You know, you heard last night from John Orr, all the new categories of how federal transportation funding is allocated, some of the categories that are being determined. His office is trying to figure out how we can make transit smarter, right? Transit's been pretty dumb for a long time, no offense to any of you in transit. It hasn't evolved like some of the other technology at the same rate. So how do we get autonomous technology to make transit more effective and efficient? Most transit agencies are a loss. They're trying to figure out a way for that to get better so that we can expand transportation, certainly into the areas that don't have transit operations now because of funding. And so really cool partnership with them. I mean, how many mayors know, how many mayors have Secretary of Transportation's number in their cell phone? So really cool opportunity. You also heard John Orr talking about electrification. We have the Metro's largest EV charging station there at our town center. In addition to that, we had a federal grant last year to develop what we're calling a mobility hub. We're going to have connectivity for PEDS, transit, all modes that are going to be public, and then having a charging station for all of those. Hopefully the transit comes up electrified as well. They'll have electrification opportunities there. And what we believe to be a future drone testing site as well. That's going to be in the corner just above City Hall. That's under development now. I'm having to go through an environmental assessment with HUD. If you ever have a bad day, try having a conversation with HUD and your life will get better. Again, this is one of those cool marketing videos. This is the entrance to the Technology Parkway off the Peachtree Parkway going north towards City Hall. There's just an amazing amount of cool stuff happening every day. It's never a boring thing. If we ever get slow, we can just look outside and find some work that we can do to evolve this project, turn it into something more effective. That even led to something called Curiosity Lab Criterion. It was just 2 weeks ago when I learned what criterion was. It's actually a French word for a bike race. We're going to have a bike race here in a few weeks in April. If you're really cool and into biking, it's called a crit, by the way. But a criterion at Peachtree Corners, we're going to have a professional bike race. They have a circuit that they go through in the spring across the United States. We're fortunate to have them coming on a Wednesday in April. $10,000 to the first prize winner, but it's going to be through the afternoon. They're going to have onboard units on many of these bikes. And so we're going to be capturing data for them using our partnership with Spoke. Those bicycles are going to be talking to the infrastructure that we have in place, just like our autonomous vehicles do, just like those of our residents who have that app that talks to our data, capturing infrastructure. So another cool opportunity for the Curiosity Lab to expand beyond even just regular traffic, regular transportation. Now we're moving into bikes, focusing on those critical users that are, vulnerable. Pedestrians and bicyclists are vulnerable, even to the autonomous vehicle to infrastructure. So it's going to be a cool opportunity for a lot of collection of data, and then just be cool to be broadcast internationally online. By the way, Europe is full of cycling fanatics. If you ever watch the Tour de France, that's what these people really get jacked up. It's like here we are in Georgia. Imagine a NASCAR Sunday. This is their NASCAR, and so this is going to be a pretty cool opportunity. This page gets fuller and fuller every time I do this. We're running out of space. These are just our partners. Georgia Tech right there in the middle, of course, and then all kinds of technology companies across the country and then across the world. This is not a Delta commercial. These are the partners' locations. Peachtree Corners, little city of Peachtree Corners, outside Metro Atlanta, is operating with partnerships in all these places worldwide. Again, it looks like a Delta commercial ad, but this is real. This is where our partners are. This is where our connections are. And what a cool opportunity for a city that's just 10 years old to be building what we believe to be the future of transportation. However small our role is, but we have a real world living lab, not a closed environment, not a laboratory at school, not in a kitchen. This is real world interaction with transportation, peds, transit, and drones. Super exciting to be a part of it. Never a boring day. So appreciate you listening today. Happy to always share about this cool project. Somebody asked me last night at dinner, what's the coolest thing you're working on right now? This is the answer. Thanks a lot. Sure.
So I was really interested in the drone battery swap.
Yeah.
My made help that battery swapping 50% in time.
It's pretty cool to see. Did you watch that happen? Again, that wasn't rendering. That was a video of it actually happening. Really cool.
How is that being used for transportation systems? Is that being used for surveying or?
A lot of it's surveying right now. Imagine other uses though, like Colonial Pipeline. They fly their pipeline aerially in an airplane. Very expensive, right? What if you could fly that with drone? And they're testing that now. Try flying their drone maybe every other day instead of once a month to see that their pipeline is safe, secure. It's not been, a tree has not fallen over. There's no maintenance issues with that. Terrorism with Colonial Pipeline would be a huge problem, right? Remember the explosion they had in Alabama a couple of years ago? Well, they started doing way more surveys, and drone is the way that they do that. For transportation, it's probably not used as much, but surveying certainly is. I've seen people use it for a boundary fence, for a penitentiary, make sure the boundary fence hasn't been compromised by a tree or other nefarious action. But just think about things that are outdoors that take a long time for a human to do, and a drone can do it in a fraction of time. So that's a huge thing. Plus the food delivery. Can't wait till my Chick-fil-A comes via drone. Yes, ma'am.
On Technology Parkway, I saw you have like for your right now. About how you serve all users, and I think we're probably, I'm not really in the context world, like probably far off. Interface those vehicles, regular non-autonomous vehicles. I didn't see where were you putting the cyclists. Are they sharing?
Right now, the cyclists are sharing the autonomous lane because the vehicle's only going 15 miles an hour. Cyclists are often going faster than that. But during the race itself, the AV shuttles are off. We're actually having to take out those zebras, which breaks my heart because it's expensive, but they're going to put them back allegedly. The bike race has lots of other rules. I mean, a bike race has to have 24 feet wide just because of the turns. They're taking a hairpin turn in the race, the course that you could see online. Very complicated, but we'll shut down the AVs for that afternoon while they're doing it. But on a normal day, the cyclists that are casual riders are riding in the AV lane, right? They still have their protection, right? And so we don't have a multi-use path, we just have a 5-foot sidewalk, and so they're operating in that lane. And that lane is just on Technology Parkway. It's just a 1.5 mile one way. It's a 3-mile loop. We are hoping to expand that loop. We're working with GDOT to take it up to Peachtree Parkway to build a wide shoulder on the outside to make that the autonomous vehicle lane so that it can have an actual circuit instead of an up and back. So we're excited about that. Hopefully it happens soon. Yes, ma'am.
So you mentioned that street corners does not get or does not have property taxes. Could you talk a little bit about where the funding for something so exciting?
Yeah, so we're fortunate we have a significant SPLOST. Our residents and have supported that for a number of years. We're very appreciative of that. That's our major funding source of SPLOST. We also have, because we're a regional job hub, we have a huge amount of business revenue tax that comes in. That's a huge source of revenue. We've gotten some opportunities for some federal grants funding through Buttigieg's offices. We're taking advantage of that. But we have a fine balance. It's always a nervous thing when I do my budget every year to make sure the SPLOST is solid. But yeah, that's a good question. And again, they get me for free, which is cool. Cool thing to say. And our elected officials love that. Love that. They're going to fight tooth and nail for that to continue. Thank you.
So we thank Greg for another wonderful presentation. Now I'm going to introduce Dr. James Tsai. Dr. James Tsai is currently a professor in the School of Civil and Environmental Engineering at Georgia Tech. He is also an adjunct professor in the School of Electrical and Computer Engineering at Georgia Tech. Dr. Tsai's research focuses on applying emerging sensing technologies, 3D laser, LiDAR, and smartphone technologies, computer vision, AI, and GIS spatial analysis to automate pavement condition evaluation and asset management, transportation safety, vehicle energy emission reduction, and safe mobility of aging population. His research project has been competitively selected for the 2017 AASHTO High Value Research Award because of successful implementation of 3D laser technologies and AI on a large-scale system. Since 2010, he has served as the associate editor of ASCE Journal of Computing and Civil Engineering. He has also served in the technical committee of NCHRP 20-102-28, prepared for transportation agencies and work zones for autonomous and connected vehicles. Please welcome Dr. Tsai.
Thank you for the introduction. So today, what I'm going to share with you is, just using cell phone. Okay. So, yes, very great. Thank you. So I think what today I'm going to share with you is the energy and emission, which is kind of big subject now. And then energy and efficient, they go by hand in hand. So the one I'm going to share with you is specifically for the one we've been working with Volvo in the Brazil, in the truck and buses. And then we kind of focus on truck and buses at this point in time. So they send out the real-time data, as well as the focus on diesel and EV. So both of them. And later on, we're going to first move to the Mercedes-Benz, which is kind of occupied the whole global trucking industry more than 40 or 50%. So currently, I think at this point in time, based on the trend and statistics, the EV is not going to take over in one day, one time. In a minute, I'm going to share with you. So in the coming 3 or 5 years, actually, the long haul, the diesel, and it's still there. But we need to cut down the energy and emission today, now. So how do we have a mechanism or a method to deal with that today? I think that's what we're going to do. I'm going to share with you based on almost last year, the one with the whole year that we get a real-time data in terms of trucking and how we come up with approaches to improve the energy and emission. That's what I'm going to share with you. And I kind of putting this one here to make that as better focus. With a key takeaway that you're going to have is number one, it's going to share with you what's the importance and all on the energy emission in transportation sector, especially truck buses in our society. That's item one I'm going to key take away. Second one there is challenging. Nowadays we have what kind of challenging? There's no mechanism or more smart data collection system to monitor how well my truck, my buses, or entire Georgia DOT, all the trucking, how well they perform. And is there any room to improve? People talking about optimize. What do you optimize? So that's second takeaway, which is challenging. There's no monitoring mechanism or system available. And the third one there is there's no sustainable data analytical framework, because if you say this bus is smart driving day 1, day 2, day 3, or the whole 30 days, how do I know each day there how much fuel consumption? What are the factors contributing to fuel consumption? How can I cut down? So a lot of time we are in a high level, say optimization, etc., but there's no down to the ground to actually see what's happening and take an action there. So that's the one that we're going to work on, which is the one we're going to focus on. The other takeaway is to study what are the factors contributing to the fuel consumption or emission. And then the other takeaway is so in terms of reducing the energy consumption, today I'm going to presenting is how we're going to reduce, how do you optimize fuel consumption from 3 areas. Key takeaway. One is mechanical optimization for the vehicle. The second, because through the working with the automobile company, they are very strong, very good in mechanical. Second is route optimization. And the third is driver behavior optimization. The last key takeaway I'm going to share with you is we're interested in a pilot. If the Georgia DOT as a whole or MATA, they're interested to cut down 5 to 10% every year the fuel consumption. We're interested in applying the mechanism to show how they can cut down right away in terms of understanding the contributing factor and then cut down the fuel consumption. That's the one I'm going to share with you. So I'm going to moving on. This is just a slide illustration, the overall framework that we have. In a way that we have the one that nowadays all around the movement. In the past, in optimization, you just try the shortest path or shortest travel time, but now you wanted to minimize the crashes, safety, but you want to minimize the fuel consumption, emission consumption too in your route. So that's the one. And today we do a lot of those green color, which is part 1, part 2, in terms of minimize will improve the safety. What do you choose the route to minimize the crashes? And then choose the route, minimize the fuel consumption, emission consumption. But today I'm going to share with you only focus on the energy part, not the safety part. So this is the one that kind of give you a statistic, which is the first key takeaway. How big deal this problem is. If you look at the almost 1 gallon of the energy there, which is CO2, which is the diesel for gasoline as well as diesel, almost can produce 8 kilogram of CO2, as well as 10 kilogram of CO2. So there's a lot of pollution. So that's why earlier I mentioned about their hand-in-hand energy. If you can cut down the energy consumption, you can cut down the fuel emission too. And just to kind of give you an idea, in the US there in 2020, transportation sector contributing to how much of the greenhouse emission? 27%. So there's a lot of room when you're talking about a carbon. You have a lot of chance to improve on this sector. In terms of energy, what's the energy there? This is the one in 2020, just statistic, right? So I'm just talking about the truck. If I say, let's make a guess, in the US, trucking, how much fuel consumption in a year? You can see here, it's almost 38 billion gallons just truck or buses just a year. That's how much they consume. How about if I can cut down 1%? That indicate you can save the money 0.38 billion gallon of the money or reduce that much of emission a year. And how about 10%? That means 3.8 billion. That's just simple math calculation. So anyway, I just kind of first key takeaway. Hopefully you see those statistics. Second, this message here, or the message I want to show it to you is this is the one working for trucking company. I mean, the Volvo automobile industry. Their vision, they do not think it in one shot immediately everything go to EV. So in a way, their customers, some of those, if that is in the city, they have a strategy. If in the city, actually it makes sense to using EV right away. But if they can't go down to long haul, really, they are not making money. So they are not going to be using EV at this point of time. They just continue using the diesel until there's better technology. And that's just the reality. You can say this is, you guys need a change, but this is just kind of showing, that's what earlier I mentioned about, it's not going to take away in one day, everything changed. It maybe take 3 or 5 years, gradually moving to EV with the technology advancement. But we need to do something now, because I think probably cannot wait in terms of cut down the emission, cut down the reduce the energy. This is the methodology we proposed. Earlier I mentioned about that. At this point in time, we recognize, I mean, in Malta driving on the roadway, GDOT vehicle driving on the roadway, do you have an idea how much fuel consumption? And then day 1, day 2, what's our contributing factor? Probably you have no idea because there's no methodology. But how did you improve, cut down? So the first step we did is, this is the one that we putting together with a system. So basically we have a smart data collection system using a smartphone. And then we're doing the segmentation based, the data collect analytic, and then doing the monitoring. So the whole idea is try to optimize. In a simple term, it's like this. You have a Malta buses, they're driving certain route. You defining and use a smartphone, you have their mechanism, which is called CAN bus, monitor what's their fuel consumption, linked together. But now you're using location reference. So for example, this mile, this 0.1 mile, I segment that. So that way, day 1, day 2, the loading different, the weather different, and etc. there. What is a different contributing factor, and what's the fuel consumption is 0.1 mile. So that way, because I can synchronize them at a data analytic framework, so I can say day 1, day 2, day 3, I have a way to integrate them. I have a way to monitor them. Day 1, day 2, what's their fuel consumption? Then I can analyze what are contributing factor. Then I can make an improvement. So it's a very systematic way to process that. So this is the one data collection mechanism we sent to Brazil, Volvo company, they're putting together. This is the CAN bus, which is in a vehicle, you can get an idea in terms of what's their fuel consumption. So as well as their RPM, toll, and all those details, you can get access on that. In the same time there, we send them, we have a smartphone application. So that way they can collect the data to extract that. So this is the total of smart data collection system. So if we want to install in the Georgia DOT, just put in there, then they can analyze that. So this is the data item being collected. Definitely, we need a fuel consumption, and then we have vehicle speed, RPM, toll, and then gear position, and all those detailed information, as well as IMU, detail XYZ, what's the driver behavior. So that way I can correlate, oh, this person here is suddenly hit the brake and even downhill still press the gasoline. This is the one almost contributing a lot of fuel consumption. So you can scientifically get an idea how, so in the future, you will not say that, oh, this is the one with the roadway with potential safety improvement. You probably say, this is a driver behavior, have potential energy saving potential. Then you can identify and improve that. You can cut down your fuel consumption. This is the one in Brazil. So this is a section they constantly collect and driving the data. This is their vehicle. So the driver through the urban area, they kind of using our data collection system. They putting the system into the vehicle, and they have different people even drive and bad driver and poor driver. This is the buses they're driving. And then, so this is, they started with in Brazil, Chile, and then Columbus probably used the EV. And this is the one kind of shared it with you earlier. I mentioned about traditional, all the people just do machine learning and time analysis. Basically, you are driving your GDOT vehicle or this Malta here just by second, but people driving different speed. How do you compare day 1, day 2, day 3? So end up with all the paper there, it's just one shot. There's cannot be sustainable to analyze the data because no comparison day 1, day 2, day 3, because you analyze the interval is every, say, 1 minute. But 1 minute you're driving today, tomorrow, the speed is different. You're talking about different terrain, different position of that 1 minute driving distance. So how do you compare fuel consumption in that 1 minute? So we are suggesting, no, you should using this methodology analysis here with the anchor point with GIS specific location. So you fix the same location. Now you're talking about Malta every year, every day. I have the same location, anchor point, 0.1 mile. So I know what's your fuel consumption. I know what's your loading, what's your gear, what's your driving behavior. So what's the input parameter and what's the output, which is your fuel consumption. Then I can scientifically analyze what are the contributing factor to this 0.1 mile. And then if you're 100 point, then you have a lot of data there to analyze what's the contributing factor. So this is the one that detailed in terms of all different variables that we analyze. This is just one interesting stuff that kind of share with you. So you can have a correlation. For example, the blue color is the fuel consumption. You correlate with the toll, which is the part of the input. You can see correlation very well, and which makes sense. If you have a toll, then you have this value here. Let me see this one here. You have the blue color here, which is the fuel consumption. And on the top there is RPM. Every people know RPM, right? Assuming you drive a vehicle. Then you will say that, wow, this is their correlation. And I'm just have a question. Why do you think this fuel consumption to 0? But this RPM is still very high. What did you expect that situation? Oh, very good. Excellent. That is downhill, right? So because downhill there, RPM is still very high, but you have no zero consumption. You kind of relieve your pedal, right? But if some people still hitting that, something is not quite right there. So through this data here, we do all the analysis here. You have a terrain, right? You need to correlate in that 0.1 mile. What's the terrain? And uphill, downhill, so you can correlate them. And then also traffic signal. What's the traffic? Is it saturated, not saturated? Those impact traffic? I mean the condition. Yes, those are the one. And then the traffic condition here. So those are the one uphill, downhill. And then what's the vehicle rolling resistance? Because you know that based on the automobile industry, they know that this is contributing rolling resistance, which is contributing almost the 17% of the fuel consumption. So, I mean, 13% of fuel consumption because the pavement there, the friction, the roughly rolling resistance from the pavement texture itself. So those are the factors there. How did you incorporate those into the analysis? This is the one quite amazing I want to share with you. Earlier, remember the important takeaway? In 1%, if you cut down how much trucking in the US is going to save, right? 0.38 billion gallon money you're going to save. But how much this one here, they're driving different vehicle and they're showing how big the difference, good and bad driver, the fuel consumption difference on the same route. But different driver, they have different driving behavior. Then you know how much energy you can cut down. So this is just the real data itself. We were just kind of presenting, showing the data. At that point in time, I'm quite curious. I asked the students, said, check, double check, check again, check again. This number is too high to reach. And then they say that's high. I think there's a report in EPA. They're talking about a big driver behavior could as high as 40% of impact. I said, oh, if that is the case, then probably this could be true. So anyway, that's the one I just showed it to you, contributing factor. I demonstrated to you, yes, you can correlate, you can analyze that. This is the one that the other idea they kind of come up with. In the future, traffic is going to impact in Atlanta, right? So for the route from Tennessee, go all the way to Florida, when is the time you're going to drive in? So we're thinking about, I should be able to create a map. It's called energy or consumption map. In every 1 hour will change, right? Thinking about if you're driving your truck, you stuck in the traffic here. And then because traffic jam, are you going to take a lot of fuel consumption? I believe so. So it's going to impact your fuel consumption. So in a way that we try to say that future, we try to create an idea in terms of map. And I just figure out that Google 2021, they already started in the program about for the sedan in terms of fuel consumption estimation, but they haven't get into truck and then the buses yet. But this is the one that thinking about that if you know different color indicating at different time, different hour, what's the fuel consumption label going to be in that 1 mile second? Then you can come up with an optimal route from Tennessee all the way to Florida. What time I'm going to route? I can cut down 10, 20% fuel consumption on that route there because you can get rid of traffic, don't stop right there, etc. So this is prediction. I skip this one here. So how did you optimize there? Certainly, I earlier mentioned about the key takeaway, right? How did you cut down? One is from mechanical, the other one from route optimization, the third from behavior. So this is the first one here. You say, what's the mechanical? Please tell me. If you look at this one here, every people drive, right? So you have common sense and then you have, so if you drive, you need to shift the gear, right? First gear, second gear, third gear. And then how much energy you need to your vehicle need to conserve, right? So when you are very beginning, start from 0, you need to shift your gear using first gear, right? At first gear, you need to use a lot of energy. But when your speed get to a certain point, you shouldn't continue using first gear. You should shift that to the second gear. Otherwise, you're going to use a lot of power, but really no need. Because in this speed here, that you can change to second gear. You can change that to third gear. So a lot of time there's a room to optimize in terms of how did you mechanistically to optimize and in terms of the right terrain, right location, you shift right here. This is the one that terrain location there. If it's different, then you probably need to use different gear. So how did you use the vehicle, the gear shift optimization, take advantage of that optimization? The other one, this is the one related about optimization. Earlier I mentioned about if you have different time, different consumption, let's say this 1 mile, then you know what's the fuel consumption at 8 p.m. to 9 p.m. or in the early morning. Then you can determine what's the routing should be. So I think that's probably almost told to. Oh, so sorry. So I think that's kind of told to the end. So as earlier I mentioned about kind of concluded takeaway. Yeah. Okay, got it. Thank you. So those are the one that is for you to optimize. Right, as earlier mentioned about if I can create a map and with a methodology, entire Metro Atlanta, and then entire nation, different hour, they have a different color. Then people can do optimization. Where is a route? I can do the planning. I can cut down my fuel consumption. As earlier mentioned about because you want to cut down the energy and then emission now. So, and we kind of try to develop a methodology can work on the diesel or EV in the future. We can cut down maybe those electrical energy. This is the one we already put in a methodology, try to find out maybe some of the pilot, some people, they're interesting to test out. For example, Malta, as earlier mentioned about, I can put in the smart data collection system, day 1, day 2, day 3. Then we can feedback in terms of what's the contributing factor. If IMU, I did not show that here in interest time. If XYZ acceleration, you kind of have a hot brake, and then downhill is still driving, you can capture that behavior. Then you can suggest to the driver, say, could you do the second day or next week, change that behavior? And can we recheck your fuel consumption? And then ideally, we're thinking about we probably can easily cut down 5 to 10% of fuel consumption, which is out of the 38 billion, if that's 100%. So there's a huge amount of potential in cut down the energy and emission. So with that, I will stop here. Answer any question.